So okay, let's solve the question that has been asked in 2024 in February shift 1. And the question is, let f defined from R to R be defined as f of x equals to a minus b cos 2x upon x square, where x is less than 0, and x square plus cx plus 2, where x is greater than or equal to 0 and less than or equal to 1. And last one is 2x plus 1, where x is greater than 1. Okay, and the next part is, if f is continuous everywhere in R and m is the number of points where f is not differential, then we have to find the value m plus a plus b plus c. Okay, and these are the options. So let's start with the solution. So here we have f of x equals to, so here we have a minus b cos 2x upon x square, okay, where x less than 0, and x square plus cx plus 2, okay. So here x is greater than equal to 0 and less than equal to 1. Last one is 2x plus 1, okay. So here x greater than 1. So this is the question, okay. So in the question, f is continuous everywhere in R. It means in this question, so here we have the dotful points x equals to 0 and x equals to 1, okay. So x equals to 0 and 1 pay, we have to check the continuity of this function. But in the question it is mentioned it is continuous everywhere. It means this function is also continuous at x equals to 0 and 1, okay. So at x equals to 0, and if at x equals to 0 this function is continuous, then of course LHL equals to RHL equals to the functional value f of 0 should be equal, and that should be defined, okay. So here we have to first check at x equals to 0. So let's find f of 0 plus. So we have to find RHL. So यहाँ से from here we can say limit x tends to 0 plus, and which function I have to consider? I have to consider this function. So here x squared plus cx plus 2, okay, and this is equal to, after putting the limiting variable value that is 0, so this will become 2. Similarly LHL, it means f of 0 minus equals to, it means LHL. So limit x tends to 0 minus, and here we have a minus b cos 2x upon x square, okay. Okay, so here we have limit x tending towards 0 minus a minus b, okay, and cos 2x is there, right? So here we have to use the series expansion of cos x. So and we know cos x equals to 1 minus x squared upon 2 factorial plus x4 upon 4 factorial, okay, or minus x6 upon 6 factorial, and so on, okay. So plus minus minus plus minus again plus minus and so on, okay, in this way. So here we have cos 2x, not a problem. So we have to just put 2x instead of x. So here a minus b, and we have 1 minus, here cos 2x is there, so this will become 2x squared upon 2 factorial plus 2x to the power 4 upon 4 factorial, or minus 2x to the power 6 upon 6 factorial, and so on, okay. And upon we have x squared is there, so this is x squared, okay. Again limit x tending towards 0 minus, and here we have a minus, so here, okay, so multiply by b, okay. So this will become b, okay, or minus 2, okay. So this will become 4x square, right? So this will become 4 x squared, okay, or into b. So okay, so this is 2 plus, this will become 16 x to the power 4 upon 4 factorial, and so on, okay, minus so on, okay. And here we have minus b into 1, so this will become, so minus is here, b into 1 b, or minus, again we have to multiply by b to the all. So this will become again, let's write b here and b and so on, and upon x square, okay. So this will become limit x tending towards 0 minus, this will be a, now distribute negative to the all, so this will become a minus b, okay. This will become plus, so b, okay, let's take b as common, so this will become 4 x squared upon 2, okay, and this minus will make it negative, so minus 16 x to the power 4 upon 4 factorial, okay, like this, and upon x square, okay. So this is there. Again we have to see here, so the value of f of 0 equals to, okay, the functional value at x equals to 0, you can see here, at x equals to 0 the value will be 2, okay, value will be 2, and since this is continuous, so the limiting value of this is equal to 2, okay. So here we have 2 equals to limit x tending towards 0 minus, and we have a minus b plus b into, this will be 4x squared upon 2, and this minus 16x to the power 4 upon 4 factorial is nothing but 1 into 2 into 3 into 4, okay. So this will become 24 and minus so on, okay, upon, this will become x square, okay. Now this limit will be equal to 2 only if a minus b equals to 0, okay. So here a minus b equals to 0, this must be 0, okay, and from here we can say limit x tending towards 0 minus b into, and this will become 2x squared, okay, or minus 16 upon 24 x to the power 4 minus and so on, okay, upon x square, okay. So again we have to take x square as common, you can see here, once you take x square as common from numerator and denominator, so this x square and this x square will be cancelled out, okay, and this will have only x square, okay. Let's write one more step, limit x tending towards 0 minus, and this will be b, okay. So let's 2 common, 2b, okay, and here x square, let's, x square is also common, x square, so here we will have 1 or minus, here if we will take 2x square common, so this will be 8x square upon 24 minus and so on upon x square. So this x square and x square will be cancelled out, and now after now putting the limiting variable value, so if we will put x equals to 0 in all these terms, so all these terms will be 0, x square is also here, and the next term will also have x, okay. So this will become 0, and if this will become 0, so we will have only 1, so this will become 2b, therefore 2b equals to 2, okay, and from here b equals to 1, okay. So b equals to 1, and we have a minus b must be 0, so from here we can say a equals to b, so this will become a equals to 1 equals to b. This will be there. Okay. So after considering the continuity of function at x equals to 0, we have a and b both are equal to 1. And again we have to check the continuity. Again we have to consider the continuity of a function at x equals to 1. So this is easy. Second one is at x equals to 1. Okay, so let's start with. So here we have limit x tending towards 1 minus, and for 1 minus the function definition is for LHL, okay, x square plus cx plus 2. Okay, so x square plus cx plus 2, and this will become 1 plus c plus 2. So this will become 3 plus c. Okay, and the limit x tending towards 1 plus. Okay, so for RHL, we have the function 2x plus 1, 2x plus 1, and this will become 2 into 1 plus 1, so this will become 3. And of course functional value at x equals to 1 equals to same, this will be there because equality sign is, okay, you can see here equality sign is here only, so same. Okay, 3 plus c, and since the function is continuous at x equals to 1, so this would be equal, so 3 plus c equals to 3. So from here we can say c equals to 0. So from here we have c equals to 0. Now let's rewrite the function. So from here we can write the function once again. So here we have a and b values are 1, right? So this will become 1 minus cos 2x upon x square for x less than 0. Okay. 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 And next one is x square, c becomes 0. So this will become x square plus 2. X square plus 2, where x is greater than equal to 0 and less than equal to 1. And next one is 2x plus 1 for x greater than 1. Okay, 2x plus 1 for x greater than 1, and x square plus 2 for x is greater than equal to 0 and less than equal to 1. Okay, and the next part of the function is, of the question is, m is the number of points where f is not differential. Okay, so let's find, because function is continuous, and if function is continuous then we can't directly comment whether the function is differential or not. Maybe differential, may not be differential, means non-differential. Okay, so again we have the dotful points as 0 and 1, so let's check at x equals to 0. Okay, and we know the function f of x is said to be differential at x equals to a. Okay, if limit x tending towards a f of x minus f of a upon x minus a exist. Okay, if this will be exist, then we can say this function is differentiable at x equals to a. Okay, so here we have to check at x equals to 0. So first of all we have to find the LHD and RHD. So LHD, left hand derivative. So from here limit, okay, we have to check at x equals to 0, x tending towards 0 minus, and here we have 1 minus cos 2x upon x square. Okay, so again we have to use the same series expansion of cos x, the x tending towards 0 minus, here we have 1 minus and cos 2x, so 1, okay, minus x square upon 2 factorial. So here we have 2x squared upon 2 factorial. Okay, and plus x4. So 2x to the power 4 upon 4 factorial, and again you have minus 2x to the power 6 upon 6 factorial, plus and so on, and upon. Okay, here we have x minus a. Okay, so this is x minus 0, and one thing we missed. So this is f of x, right? F of x 1 minus cos 2x upon x square, and we have. Okay, so let's. Okay, so here minus. Okay, so here we have. Okay, so here we have. So this is f of x minus f of a. Okay, so what is the value of the function at x equals to 0? Of course 2. So minus 2 f of a, and upon x minus 0. So this is x minus 0. It means x. Okay, so this is there. Okay, so this is 1 minus cos 2x, expansion of cos 2x is there. Okay, and upon here x squared is there, and here minus 2. Now this is complete. Okay, so let's move further. So here we have, now this implies limit x tending towards 0 minus. So here we have 1 minus. Okay, so this will become 1 minus, so this will become 4x squared upon, so this is 2. Okay, plus 16x to the power 4 upon 24. Okay, and minus and so on, and here minus 2, and upon x squared is there, and the whole upon x is there. Okay, so little bit lengthy. So now this implies limit x tending towards 0 minus. Now you can see here, if you will distribute minus to the all, so this will become 1 minus 1. Okay, this will become plus 2 2s are 4, so this will become, so this will become 2x squared. Okay, and this will become minus 16x to the power 4 upon 24 minus and so on. Okay, and this will become, okay, minus 1 and minus 2, so this will become x squared, 2x squared, and upon this x squared and x will become x cube. Okay, this will be there. Okay, so from here, now this implies limit x tending towards 0 minus this minus 1. Okay, and plus 1 will be cancel out. This plus 2x square minus 2x square will be cancel out. Okay, and we have minus 16x to the power 4 upon 24, and minus so on upon x cube. Okay, so now you can see it very easily. This implies, after putting the limiting variable value, so we have to just take x cube common from the numerator, because after this term, okay, 16 into x to the power 4 upon 24. Okay, again we will have some x to the power. Okay, and from all those terms we have to extract x3 as the common, x to the power 3 as the common. Okay, so again limit x tending towards 0 minus, so this will become minus 16x upon 24, okay, and minus, and so on. Okay, this x cube will be cancelled out. Okay, and after putting the limiting variable, that is x tending towards 0 minus, that is x equals to 0, this whole term will become 0. So the answer is 0. Okay, so LHD at x equals to 0 is 0. Now let's find RHD. RHD. Okay, so limit x tending towards 0 plus. So for 0 plus we have the function x square plus 2. Okay, so x square plus 2. Okay, x square plus 2 is there, right? So this is the function and we have to find the RHD. So this is f of x minus f of a. Again f of a equals to 2 and upon x minus 0. Now this implies limit x tending towards 0 plus. So again this minus 2 plus 2 will be cancelled out and we have x squared upon x, and again this will become 0. It means LHD, RHD exist and are equal. So LHD equals to RHD equals to 0. It means the function is differentiable at x equals to 0. So 0 is the doubtful point, and at 0 we came to know the function is differentiable. Now again we have to check at x equals to 1. Now at x equals to 1. So again we have to find the LHD and RHD. So again LHD, that is limit x tending towards 1 minus, again the function is for LHD. Okay, so here we have the function x square plus 2. So x square plus 2. Okay, so this is the function minus, and value for this is 3 upon x minus 1. Okay, now this implies limit x tending towards 1 minus, this will become x squared 2 minus 3, that is minus 1 upon x minus 1. Okay, we know x squared minus 1 equals to x plus 1 or into x minus 1. Okay, so this x minus 1 and this x minus 1 will be cancelled out and we are left with limit x tending towards 1 minus, and we will have x plus 1, and this will become, after putting limiting variable, so this will become 2. So LHD is 2. Let's find RHD. Okay, RHD. So again limit x tending towards 1 plus, function is 2x plus 1. Okay, and value is again 3 upon x minus 1. Okay, so now limit x tending towards 1 plus, and here we have 2x 1 minus 3, that is minus 2 upon x minus 1. Okay, and you can say 2x minus 2 upon x minus 1. Okay, so this will become 2 into x minus 1 upon x minus 1. This will be cancelled out, so this will become 2. So RHD also 2, LHD also 2. So at x equals to 1, again the given function is differential, right? So here LHD equals to RHD equals to 2. So it means at x equals to 0 and at x equals to 1, the function is differential. Okay, and from here, from the question, let's come to the question. So here we have, if f is continuous everywhere in R, okay, and m is the number of points where f is not differential, then m plus a plus b plus c equals to, okay, so m is the number of points where function is not differential, so this will be 0. Okay, this is differential at x equals to 0 and at x equals to 1, and a plus b plus c value, so a equals to 1, b equals to 1, and c equals to 0. So the required value will be, so from here we can say m equals to 0 because there is no point. where the function is non-differential. So therefore m plus a plus b plus c. So this will become m is 0 plus a is 1 plus b is 1 plus c is 0. So this will become 2. So 2 is the answer. As simple as that. So this question is completed. So the answer is, let's check the option. Okay. So 2 is the answer. Okay. So this is there. Okay. So let's solve one more question. Okay. That has been asked in again 2024 in February, 1st February shift 2. Okay. So here we have the question f of x equals to, okay, mod 2x square plus 5 mod x, okay, minus 3, where x belongs to r. Okay, if m and n denote the number of points where f is not continuous, okay, and not differentiable respectively, then m plus n is equal to, okay, so m represents, okay, is not continuous, where m represent number of points where function is not differential. Okay, or similarly n is also represents number of points where function is not differentiable. Okay, so let's solve this. So here we have the function f of x equals to mod 2x square plus 5 mod x minus 3. Okay, so first consider, so here we have the function, let's write once again, plus 5 mod x minus 3. So first consider what we will do. Let's consider g of x equals to 2x squared plus 5 mod x minus 3. Okay, and we can also write it as 2 mod x squared, okay, and plus 5 mod x minus 3. It means we will have the function as 2x squared plus 5x minus 3. Okay, so first of all, suppose we would have the function as this, h of x equals to 2x squared plus 5x minus 3. Okay, so this is quadratic expression. Okay, so let's find its root, and we know how to draw the graph for quadratic expression. Okay, so let's find its root by splitting middle term. So 5x, so why I am doing this, you people come to know. So let's find its roots. So 2x square, okay, plus 6x minus x minus 3. So this will become, let's 2x common, so x plus 3 minus 1x plus 3. Okay, so this will be 2x minus 1 into x plus 3. So okay, its roots will be 1 by 2 and minus 3. Okay, okay, so let's draw the graph for this quadratic expression. So okay, okay, so its roots are minus 3 and 1 by 2. So minus 3 is here, 1 by 2 is here. Okay, and you can say here, so here we have ax squared plus bx plus c. This is the quadratic expression where abc belongs to r and a not equal to 0. So here a equals to 2, that is greater than 0. It means the graph will be upward parabola. Okay, and roots are this. Okay, and how to find the y-intercept? By putting x equals to 0. So here we have 2x squared plus 5x minus 3. Now putting x equals to 0, we are left with minus 3. So the graph will be, okay, okay, look like graph because this is freehand sketch. Okay, so the graph will be like this for h of x. Okay, now if we'll put mod over x. So this will become, first of all, we have h of x is this. Now I am taking mod of x. So this will become 2 mod x square, okay, plus 5 mod x minus 3. Okay, and we know in the chapter function transformation of graph. Okay, so suppose we have y equals to f of x. Okay, then if we have to draw the graph of f of mod x, so what is the rule? The rule says, okay, so the rule says we have to remove all the portion of the graph which are on the left hand side of the y-axis. Okay, so let's remove. Okay, we have to remove all the portion of the graph on the left hand side of the y-axis and make the same graph as on the right hand side. So let's remove this portion and make the graph like this. Now this will become, so this is, okay, okay, just make, so let's make here, so this is minus 3. Okay, so this will be like this. So this is 1 by 2. So we have to just remove this portion and we have to make the same graph as on the RHS, right hand side. Okay, right hand side of what? Right hand side of y-axis. Okay, so here 1 by 2 is there. So here we have graph will be like this, and this will be minus 1 by 2. So this is 1 by 2, this is minus 1 by 2, and this will be same minus 3. So this is the graph for this. Okay, now again, if we have y equals to f of x, then what is the graph of this? Okay, so what is the rule? We have to just draw the graph which are below the x-axis. Okay, that will go above x-axis. This is the rule. So here we have h of mod x equals to 2 mod x square. So again, mod x square or x square, both are same. Okay, so 2 mod x square plus 5 mod x minus 3. So here we have this mod x square or x square, both are same. So plus 5 mod x minus 3. Now this is the question, and we know if we have y equals to f of x, then to draw the graph of y equals to mod f of x, so the graph which are below the x-axis will go above the x-axis. So here we have the graph. So now the final graph will become, so the final graph will become, okay, so this will go above x-axis, right? Okay, okay, so this is minus 1 by 2, so this is 1 by 2. Okay, and this is 3. So this is the portion, this portion which are below x-axis, okay, will go above x-axis. We draw this, and this is the graph of f of x. Okay, this is the final graph of f of x. Okay, so from graph you can see very clearly. So there are 3 points. So here there are 3 sharp edge. So this is first one, this is second one, and this is third one. And we know that at sharp corner, the function is non-differentiable. But there is no breakage throughout the graph. So there is no point of discontinuity. The function is continuous everywhere, but function is non-differentiable at 3 points. So we have to find the value of m plus n. So m represents number of discontinuity, number of points of discontinuity. So this will become 0, n will become 3. So the final m plus n equals to 3 plus 0. So this will become 3, and fourth option is there. So this is the answer. Okay.